All right, hey everybody, it's Mr. Hauser. Thanks for joining me. Today we're going to do a math lesson that focuses on shapes. I know we've done some other lessons that focus on triangles and circles and squares, but this one's going to be way harder. I mean more complicated. Try again. This one's going to be a good challenge because it's going to focus on a large group of shapes instead of just one specific type. Okay, so we're going to look at what's called the quadrilateral family tree. And the idea behind there is not just to look at very specific rules and long names, but to connect to shapes that you may have already seen. So you get to see some of the differences and in what ways they sort of trickle down into these smaller groups. The reason I said family tree is because if you think of like a family tree, there may be a set of grandparents, and then those grandparents have one of your parents, and then they make their family, an aunt or uncle, and they make their family, another aunt or uncle, and they make their family. So it sort of trickles down into other groups that all have one thing in common. They're all sort of connected in one way, but there's also some differences. They may live in different houses, have different names, and so forth. So that's how my family is, at least. So we'll look at that. Before we jump into that right away, there are a few specific things that I'm going to reference that are going to be helpful if you know. All right. The first says equal sides. All right. Now, equal sides are going to be sides that are the same length. And so if we look at a shape that might be familiar to you, we can see that this one has 4 equal sides. All right. No matter how I turn it, the length of the side is still the same. If we look at another shape that may be familiar to you, you can also see that these sides, while they may not be straight up and down and side by side, the sides are still the same. Okay? And how do I know that for sure? Well, I can use this one that I believe is the same on all sides, and I can say, okay, that one's the same length, that one's the same length, that one's the same length, and that one's the same length. So there we go. We have 4 sides that are equal. Equal sides means that they are all the same length, or that they are the same length. If I look at this shape, I can see that 2 of these are not the same. In fact, 3 of them are the same and 1 of them's not. Is it? No. Yep. That one's the same as that and that. But if I measure that bottom one, I can see those aren't the same. So those are not equal sides. This is a shape that has 3 equal sides and 1 that is not equal. All right, take a look at that one. Does that have equal sides? Well, let's take a look. Equal sides. All right, so equal sides mean the sides are the same length. Got it? Okay. The next one is parallel sides. Now, parallel means that the 2 lines go side by side, and if you continued those lines forever, they'd never meet each other. Okay? And so in some of the cases I just showed you, you can see that the 2 lines on the line on the top, the side on the top and the bottom are parallel, because if we continued to draw those lines, they'd never meet. Okay? If we looked at this shape, again, they'd never meet. They're parallel. However, if I looked right here, I can see that this has 2 sides that are parallel, but if I were to continue the sides here that are going up, that if I continued those, they would hit. So does that mean they're parallel? No, these are not parallel if they're going to meet. Okay? And so we'll look at parallel sides. Parallel just simply means that the 2 sides that are opposite of each other will never meet again. Okay? The last one is called a right angle, or right angles. And those are when 2 lines make an angle that is straight up and side by side and straight up and down. Okay, this is a right angle. This would be found in a square or a rectangle. This is a right angle. This is smaller than a right angle. This is smaller than a right angle. This is smaller than a right angle. Okay, this is a right angle. This is bigger than a right angle. This is bigger than a right angle. This is bigger than a right angle. So you can see that while a square has those right angles, This shape, what makes it different, even though all four sides are the same, is because that's not the same, that's not a right angle. It's too small. Whereas this corner at the bottom where my thumb is, that one's too big. All right, and so if an angle where the measurement of the two sides coming together, if that's too big, it's not a right angle. If it's too small, it's not a right angle. Right angle has to be straight up and down and side by side like that. All right, so what I had drawn is two lines, and I put a little box there just to show that it comes from a square, so that's a right angle. So knowing these is going to be very helpful. All right, so let's go check out this family tree. Now, like most families, I know I have that family where there's a group that we don't talk a lot about. They're sort of an odd group, and many families have them. They're not, they don't come to the regular meetings or phone calls or Zoom meetings, but they're still part of our family. You can't deny them. These are the irregular shapes. These are the quadrilaterals that are just simply quadrilaterals. They're called irregular, which means like not regular in any way. Like there's nothing special about them. They don't have equal sides. They don't have parallel sides, and those are going to be found in some of the other families. This group is just sort of out there. They have four sides. It's to show you that you can put four sides together without having anything else special about it. Okay, these are called the irregular quadrilaterals. If you were to give it a name and go, oh, wow, what's that shape? You just say quadrilateral. All right, it's sort of like the basic family name, right? So let's move into some of the smaller families that do have specific rules, okay? The first one are trapezoids. Now, a trapezoid has one set, and when I say set, I mean a pair of lines that are parallel, okay? And so trapezoids can look like that, sort of. Let me show you some better trapezoids that are a little more precise. So here are a couple trapezoids, because you can see on the top shape, the top two lines are parallel. That means they're never going to meet. The bottom one, you can see it's the two side lines that are parallel, right? These two lines, the top and the bottom, would actually meet somewhere over here. And this line would eventually meet too. So those are not parallel lines. They only have one pair of parallel lines. The other sides of it are not parallel. Okay. One of the common ways of seeing this is in shapes that look like this. And this is a little more special because these sides are maybe not parallel, but they're equal in these cases. That red shape that I showed you earlier is a trapezoid, okay, because it has one pair of parallel lines. So whether the trapezoid looks like that or like this, it's a trapezoid because these lines are parallel. They run side by side. These lines are parallel. Okay, so in a trapezoid, there's one set of parallel lines. Now, what happens if you had two pairs of parallel lines? Well, that's where we lead into the parallelogram. And so parallelogram is often shown by a shape that looks kind of like this. Okay, and that's because this one is parallel to this, and this one is parallel to this. All right, so a parallelogram has two pairs of parallel sides. The top and the bottom are parallel, and the side and side are parallel. Now there's some special types of parallelograms that we'll move into, okay? If we took that angle and sort of straightened it up so that it had right angles instead, then it would look something like this. This line is parallel to this, and this line is parallel to that. But now, all the angles are right angles. When we have that special type of parallelogram, what does that look like to you? Yeah, that is a rectangle. All right, so we get a rectangle. That's like one of the kids in the parallelogram family is a rectangle, because those are the ones where the sides, they're equal sides here and here, and equal sides here and here. They're not all equal, but they have parallel lines on they have two pairs of parallel lines, okay? Now, we can take that and even move it even more special, because a rectangle has two pairs of parallel lines, at least two pairs of equal lines, and then it has right angles all the way. Now, what if we were to shrink those sides so that all four sides are equal? Then we would get a shape that looks like this, where this is equal to this, and this is equal to this, but all of them are equal. Not only that, they have four right angles. Well, what's that shape? That's the one that we know, right? Let's see if I can get the size just right. Boop, there it is, right? So that is our square. That's how we get a square. So a square is actually a special type of parallelogram. And in fact, not only that, but it's a special type of rectangle, because all the rules that apply to a rectangle are still rules that a square abides by, okay? So parallelograms can either follow this track of becoming a rectangle, or even more specially a square, or a parallelogram can fall into another group, which means if they don't have the right angles, but this is equal to this, and this is equal to this, and they're all parallel and equal, we can't call that a square because it doesn't have the right angles. That one, you could see, go back to this, is the blue shape that we typically have in the classroom. This has a special name as well. It's not a rectangle because it doesn't have the right angles, and it's not a square because it doesn't have the right angles. But this is called a rhombus. All right, and a rhombus is one that has, looks like this. Now, if we squeezed it together so that they're, you can see that this does not, as we said before, it does not have right angles. Those angles don't go straight up and down. These are more, the two ends are smaller than a right angle, and the two on the top and the bottom are bigger than a right angle. Okay, so we can't call that a square because it doesn't have right angles. But take a look at this one. If we squeezed it even more, that's a rhombus as well, because all four sides are equal. All four sides are equal and parallel. All right, so there are two sets of parallel lines, and all sides are equal, so that's a rhombus as well. All right, so that's how we can get from a parallelogram to a rhombus, is to make all four sides the same size, but don't make them so that they have right angles. All right? All right, so let's go ahead and take a look at the next group, which are the kites, or diamonds, if you will. Now, a kite or diamond has two sides that are equal and two pairs of sides that are equal. You can see it kind of looks like a kite. The thing is that makes a kite different than these other ones is that the equal sides are right next to each other. They're not opposite each other, but they're right next to each other. So a kite or a diamond has this side is equal to this one, and this side is equal to that one. Okay, that would make it a kite or a diamond, because the two sides that touch each other that are side by side are equal. Okay, it doesn't matter. In this case, you're not going to get right angles, but you can make it a little bit more special. So if you were to take a kite and make this line equal to this line, equal to this line, and equal to that line, then you know what you get? You get a rhombus. Okay, so it's sort of like, it's like that family member that's really comfortable in two different households, or like, oh yeah, it's a cousin, but they're just like my brother. That's kind of how a rhombus is, where you can get to the rhombus from two different angles, okay, from two different paths. And so what we can see is this rhombus actually is quite special, because it starts off as a parallelogram, but a very special type of parallelogram called a rhombus. But we can also call it a kite, or in many cases, people look at this and go, oh, that's a diamond. Even on some name tags and other math materials that are a little less technical, we'll call this a diamond. Well, a lot of kids come in kindergarten thinking this is a diamond if they don't know the word rhombus. And so it does fall into that group of diamonds or kites, but it's a special type of diamond, a special type of kite, where all four sides are the same. Okay? So let me show you one more that is also a special type of kite or diamond that turns into a rhombus because all four sides are the same. So let me show you some shapes, and you guys tell me if you can figure out what it's called. Okay? And we'll talk quickly about why it is called that. All right, let's start with this one. Take a look at it that way. All right, that is a kite or a diamond. It's not a rhombus because all the sides are not the same. But in fact, you can see there's a right angle up in the corner, but that doesn't really matter. What we have are the two sides that are equal are these two, which are next to each other, and the other two are right next to each other too. So there's two sets of equal lines, but they're right next to each other, which makes it a kite. All right, hopefully you said kite. Let's take a look at this one. All right, in that case, you can see again, we have equal lines next to each other, but in fact, all four are equal, which makes it a rhombus. A rhombus. All right, let's take a look at these. What do we have here? We have two of them, big and small, but they're both rectangles. Exactly, rectangles because they have parallel lines, two pairs of parallel lines, and in this case, they both have right angles. In each of the corners, it goes straight up and down, or straight side by side. Even if I put it askew like this, just take a look at it like this, and it's still a rectangle. All right, don't let that fool you. All right, let's take a look at these. What are these? Big and small. We have squares. You got it. And that's because we have four sides that are all equal and parallel. And they're parallel because, which includes a right angle in each one. Okay, that makes it different than a rhombus is the right angle. Okay, what makes it different from a rectangle is the fact that all four are the same size instead of just two that are the same size and two that are the same size. Okay, all right, let's see, what can we call this? I know it's a long word. It starts with a P. This one is a parallelogram. Okay, and that's the most specific we can say about it because all four sides, it kind of looks almost like a rhombus, except all four sides are not equal. These are shorter than these, okay? But it does have two pairs of parallel lines, which makes it a parallelogram. That's where it comes from. That's why it's called parallelogram, because it has two pairs of parallel lines. All right, what do we call this? If you also said parallelogram, you are correct, because we have parallel lines. The short ones are parallel, the long ones are parallel. We don't have any right angles, which means we can't call it a rectangle or a square. And so it just stops at parallelogram. All right, let's take a look at the last one, see what you can see. All right, so you've got three different size squares. Three different size squares. You've got a small red one, a slightly bigger green one, and then a big yellow one. All of them are squares because they're created by right angles and four equal sides. Okay? Now, not to be forgotten are just the simple quadrilaterals. These don't belong to one of these other three families because they don't have any parallel lines. They don't have any equal lines. They're just four sides that come together. These are irregular quadrilaterals or simply just quadrilaterals. Okay? So that's a mouthful. I know I need to rest my tongue and my cheeks after doing this lesson, but hopefully it explains what some of these shapes that are commonly used in the classroom can fall into, what groups they can fall into. So this is a square. We'll call this a square. Okay. This is a trapezoid because it has a pair of parallel lines, and then these two are both examples of rhombuses, or rhombi. Ooh, let's not go there. Okay, so this one's a rhombus and this one's a rhombus. There, I'm going to avoid using the plural form of it. And so these are both an example of a rhombus because they have 4 equal sides, but what's missing is those right angles, okay? If it did have a right angle, if I said, hey, rhombus, sit upright, and it straightened itself up, then it makes itself into a square. So they're very similar, okay? How's that going? Was it too tough? Gives you something to think about. But that's where we have our quadrilateral family tree. Quadrilateral, I always think of in Spanish, the word for 4 is cuatro, or cuatro. And so quadrilateral starts with the very similar sound. And that's because any shape that has 4 sides is a quadrilateral. Is a square quadrilateral? Yes. Is a rectangle a quadrilateral? Yes. Is a diamond a quadrilateral? Yes. Is a trapezoid a quadrilateral? Yes. Is a triangle a quadrilateral? No. A triangle has 3 sides. Quadrilaterals have 4. Okay? So, let that settle in. Watch this video 5 or 6 times before you get to 5th grade, and then you'll get it. Okay? All right. Take care. Thanks for watching, and I will rest my mouth now. Bye.